Hello, Geometry. This lesson is entitled Deductive Reasoning. So what is deductive reasoning? Deductive reasoning is a process of reasoning logically from given facts to a conclusion. And that's the slight difference here with deductive and inductive reasoning. Inductive reasoning was trying to recognize that pattern and coming up with that conclusion, whereas deductive reasoning is reasoning logically from given facts to a conclusion. Okay? We go off of facts to come up with a conclusion for deductive reasoning. Now this lesson is going to deal with two main laws of deductive reasoning. The first one is called the law of detachment. Well, the two are the law of detachment and the law of syllogism. So the first one is the law of detachment. I'm just going to read this property here. It says, if a conditional statement is true and its hypothesis, keyword, hypothesis is true, then its conclusion is true. So if P then Q is a true statement, and the first part, the hypothesis, P, is true, then Q is also going to be true, the conclusion. Okay. So for the given true statements, what can you conclude? For example here, given, if M is the midpoint of a segment, then it divides the segment into two congruent segments. That is true. If it is a midpoint, it divides the segment into two congruent segments. So we can establish that the conditional is true. Okay, again, we recognize this part. If the conditional is true, and its hypothesis is true, well, it's telling us that M is the midpoint of AB. Okay, and notice we're talking about M being the midpoint of a segment. Well, it does tell us M is the midpoint of AB. So what's the conclusion that we can come up to? Well, I'll write it in two kind of different ways here. So our conclusion will be this. M divides AB into two congruent segments. Or another way of saying that, another way you could write that as a conclusion is you could say AM, since M's the midpoint, is congruent to MB. So that would be another way to write the conclusion. So again, we have the conditional that's true, and then we say something about the hypothesis. M is the midpoint of AB, therefore our conclusion is that M would divide AB into two congruent segments. So this is a way of using the law of detachment. So now here we have a new problem. Does the following argument illustrate the law of detachment? So the question is, again, does it? Does it follow the law of detachment? Here's the conditional that we're given. If it is snowing, then the temperature is less than or equal to 32 degrees Fahrenheit. That has to be true. That is the freezing point. So the conditional is true. Notice here it says the temperature is 20 degrees Fahrenheit. Now the question is that talking about the hypothesis or conclusion? Because with the law of detachment, remember that the law of detachment says, back on the first page, says if the conditional is true and its hypothesis is true, then the conclusion is true. But here, on this one, the temperature is 20. That's actually talking about the conclusion. So can we conclude that it must be snowing? In this case, no. This does not follow the law of detachment, because the second sentence that we are given is talking about the conclusion, not the hypothesis. Because if it's 20 degrees Fahrenheit, that doesn't mean it's snowing for sure. Could it be snowing? Sure, but it's not guaranteed that at 20 degrees Fahrenheit it will be snowing. Now, to make this true, if the second sentence were to say it's snowing, then that does follow the law of detachment, and our conclusion could be, or would be, that it is equal or less than 32 degrees Fahrenheit. So again, the key with the law of detachment is that the conditional statement is true, and the hypothesis is true. Again, the temperature is 20 degrees Fahrenheit is talking about the conclusion. So this does not follow the law of detachment. Now, the second one is called the law of syllogism. Okay, some people refer to it also as called a logical chain. If one thing happens, then if P happens, then Q happens. Well, if Q therefore happens, then R is going to happen. That's the property here. If P then Q and Q then R are true statements, then P then R is a true statement. So again, a logical chain. The use of the law of syllogism to draw a conclusion, use the law of syllogism to draw a conclusion from the following true statements. If a number is prime, then it does not have repeated factors. If a number does not have repeated factors, then it is not a perfect square. With the law of syllogism, what you're looking for is a conclusion that has the same wording as another hypothesis of another sentence. So therefore, what we can do is cross these out. Basically, these cross each other out. A conditional and a conclusion and a hypothesis that are the exact same will cancel each other out. Notice what we're left with. We're left with, if a number is prime, then it is not a perfect square. Again, those two middle phrases, since they were the same, the conclusion of the first and the hypothesis of the second were the exact same. So those got crossed out, leaving us with, if a number is prime, then it is not a perfect square. That is what we call using the law of syllogism. Okay? Now for some of these, well actually let's do one more here, or a couple more. If possible, state a conclusion using the law of syllogism. If it's not possible to use this law, then explain why. Here the first one says, if a number ends in 0, then it's divisible by 10, which is true. The second conditional says, if a number is divisible by 10, then it's divisible by 5, also true. So notice here we have a conclusion, it is divisible by 10, and a hypothesis, a number divisible by 10, that are the same. So we can actually cross those out. Therefore, we can use the law of syllogism to come up with our conclusion. And that conclusion would be, if a number ends in 0, then it is divisible by 5. Again, these two in the middle crossed out, leaving us with this hypothesis and this conclusion. If a number ends in 0, then it is divisible by 5. I do want you to notice that our answer to the law of detachment problem is just a sentence that's not a conditional. Okay? Whereas the answer, when we use the law of syllogism, the conclusion is a conditional statement. Okay? So know how to phrase your answers for each of these. Now let's try this one. If a number ends in 6, then it's divisible by 2. If a number ends in 4, then it's divisible by 2. Now both of these are true, yes, but there is no hypothesis and conclusion that match up. Here our conclusion is divisible by 2. The next hypothesis ends in 4. Those are not the same. So therefore, we cannot use the law of syllogism. Again, therefore we cannot use the law of syllogism. Okay? The hypothesis and a conclusion need to match up. Now sometimes the sentences will be out of order, and so it won't be nicely set up for you, but if you can rearrange them to where a hypothesis and a conclusion will actually cancel each other out, then you can still technically use the law of syllogism. So just want to state that they don't necessarily have to be in the exact order as we've been doing them. Okay? Now here it wants kind of to use a combo. Use the law of detachment and the law of syllogism to draw conclusions from the following statements. So what we're actually going to do is use the syllogism first. If a river is more than 4,000 miles long, then it is longer than the Amazon. If a river is longer than the Amazon, then it's the longest river in the world. So right away, we notice that this this conclusion matches up with this hypothesis. So technically we can say if a river is more than 4,000 miles long, this is using the law of syllogism, then it is the longest river in the world. Okay? Well, the next sentence, notice it's speaking to the hypothesis. Okay? If a river is more than 4,000 miles long. Here it says the Nile is 4,132 miles long. So again, it's speaking to the hypothesis. So therefore we can come up with a conclusion using the law of detachment. So our conclusion would be, The Nile is the longest river in the world. So since it is more than 4,000 miles long, we can say, then it is the longest river in the world. Okay? That is using the law of detachment and the law of syllogism together. So I hope that helped explain things, and I hope you guys understood that. So good luck with that.